Hi everyone, and welcome to the following of reputation.sol. In this part we're going to compile the smart contract and also deploy it so that we can see how it works. So here I'm going to press Ctrl S in order to save it, and now let's compile it. So here it says user.name. So okay, here we need commas here and here, so we forgot that. Save this and 3 more errors here. So reputation score is written in the wrong way, probably. So here, yes, this is reputation score. Should be written this way. So this is related to updating the reputation if you cannot find it. So actually here is underline, and here is also underline because we'll get this from the user. And so if we save this, the errors are all gone and the smart contract is compiled successfully and we can deploy it. So here let me deploy it with the first address, and now we can open the instance of the deployed smart contract. So here we will register the user at first, so you can enter a name. So for example, Alice as the first one, register the user, and we can register, for example, Sarah. So you don't necessarily need to have the different addresses for registering the users. We just enter the username and no address is required. So here we can first of all, let me get the user. So here you can enter the address of the user. So let me enter the address and call this, it's Sarah. So actually if you enter another name, it will update the username, right? So you need separate addresses actually here for each one of the users, because we will retrieve them by the address. So Sarah and Alice. Or you can, if you don't want to update the name, you can add the requirements that the or a kind of an event for the address and the user, and if the user there is a user for a specific address, then we cannot enter another name, right? But this way gives us this capability in order to change the name if there is anything wrong with the address. So if, for example, a certain address has a specific name and that has been entered incorrectly, then we can change the name and update it. So it's totally up to you if you want to be able to update the names or not. So it's really important in some smart contracts, and in the other ones it doesn't matter what the name is, it's just the address that matters. So this is really an important note that you need to consider if you are writing the smart contract, especially if it's a commercial use smart contract. So anyway, here we have the get user from the get user function, but here even with the struct that we have defined or the array, we can also retrieve the user. So username reputation score is 0, and we can call this the same data comes over here. So here with this function we can count the users. So actually here there are 3 users entered, but actually we should also write something in order to manage that, because once we enter a user with the same 2 users with the same address, there shouldn't be 2 users, right? So this is an important thing to consider as well. So we should, when writing the smart contracts, at first we do not see these details, but when we go after testing them on Remix, we'll notice these problems, and then we need to think about solving them. So one of the other ones that we faced was this reputation score, but then we noticed that problem and added the necessary requirement to the function update reputation, right? So the user count is also important to manage, because once an address has been given the user, then the user shouldn't be incremented, right? So if it's the same address that has been entered, we shouldn't have any user added. So this is a necessary requirement which we will work on in the future. But right now we have update reputation. So here you can do the most important part. So for example, for a specific address like this address, or the one that we're just registering the user, you can add the user, update the reputation score. Also notice that each person needs to be able to give the reputation score only once. It's just like voting. So if the person has voted, he or she will not be able to vote again. So this is also true for the reputation score. Otherwise, the person will be able to give this reputation score to himself or herself for infinite number of times and be the winner of it. So these considerations are very important. If you don't care about them, the whole system is a bug and it doesn't work anywhere, right? So we'll give a reputation score. Let's consider giving it 12 because it's the wrong one. And so here I can enter a comment. So my comment, for example. So as you can see, we will get this error: reputation score must not be greater than 10. So let's give it 8 and transact. As you can see, it's been done successfully. Let's transact again. As you can see, it's the bug of the system. We can give the user a couple of times, the score a couple of times, even infinite number of times, and this is a bug. If we get the user, if we get the user, call user, as you can see, the reputation score is 16 now, which shouldn't be. The user needs to, each user needs to be able to give the reputation score only once, and if there are other times, then it shouldn't happen, right? So let's think how we can solve this. In order to manage this kind of problem, we need to actually create a kind of an event for the reputation score given. Is like just the voted events that we would emit at the time that a specific user who is the message sender has given the vote. So this is also true about the updating the reputation. So here we can take a look at our voting smart contract that we wrote previously. So let's take a look at the events that we had the vote casted event, which would get the candidate ID and the voter, right? So the address of the voter here matters, and also the candidate ID. So the message sender should be able to give the reputation only once for a specific candidate ID or in any specific ID of the users, right? So we can just copy and paste this one right over here and apply it here, but there's a small difference between the reputation.so and the voting, well, casting the votes, and that is that the when a person gives a vote, then cannot give a vote to another person, right? This is just a one-time thing. But in the case that we're working on, it's not a one-time thing for the whole project, right? The whole process, and this is only a one-time thing for a specific user that he or she wants to vote her or him, right? So here let's get back to the reputation and add the event and try it together. So I'm gonna add the event and rename it to reputation. So actually this is the reputation updated. So actually if we take another look to the smart contract of voting, this is not the case of checking the whether the user has been voted or not. So we have the reputation updated just the same, but actually we need a kind of a mapping from the let's take a look at the voting smart contract first. So vote3.sol, here we have the has voted as well, and this is a mapping from the address to the boolean. But here the problem is that we want a mapping instead of a mapping, right? Meaning that we have one address, the person who gives the score, to another specific user, right? So this is not just a simple mapping like this. This is a mapping inside of another mapping. So in order to do so, we need to also create another layer of mapping, so that, for example, here it checks the requirements of the user who's going to vote. So the message sender is the first one, and the second one is the address of the person that he or she wants to vote to, right? So then we'll have this checkup and this requirement inside of our give score. So it will then not let the user to vote for a repetitive number of times, actually give a score for a repetitive number of times. So if you look at your previous smart contracts, you can solve your own problem this way when you're learning the Solidity. So you don't necessarily need to search for that kind of problem or for the thing that you want to solve. You can take a look at the similar kinds of circumstances that you had in the previous contracts and solve your problem. Even if, for example, right now you're stuck in the middle of finding how to write a mapping instead of another mapping, we have done this in our previous smart contracts. You can just take a look at them and see how they worked. So for example, in the multi-signature valid smart contract, here we had a mapping within another mapping, uint256 to a mapping from the address to bool. So let's take a look at how this mapping worked. So and actually it was another boolean kind of mapping. So let's find how it used to work. So you need to find something like this, is approved. So it will get the transaction ID and also the signer, right? So for each transaction ID there was a signer, and we wanted to check if that a transaction ID that the signer signed is approved or not, right? So there is there are two kinds of mappings within each other. So we want to do the same here. So now let's, given all of this data that we have right now, let's write it together. So I'm just giving you the idea of how to think at the time of learning and how to use your previous smart contracts and previous experiences in order to write the new smart contract and be able to comprehend. So here I will add another mapping, and then this mapping is actually, let's write the user the name of it first. Public has updated the score, or has given the reputation a score. Has updated reputation. So this is a good parameter for checking, and we have a mapping here. So let's take a look at vote 3. Here we had a kind of a mapping for here the address to the boolean, right? So we will have the address to the boolean, just like the same we had here. So the boolean was at the end, but here instead of uint256 we have an address. So in the end, if you don't understand anything, if you don't get anything, don't worry, because you will understand. So we will go on, and then so here this is the address to the mapping, and that mapping is from the, again, address to the boolean, and the end boolean here has updated the reputation. Let's take a look at here. Again, here this boolean parameter was at the end, so from this ID to this address the end result should be a boolean, and we'll check that. So just the same we will have here in the reputation. So anyway, once we have defined this mapping, we will instead of the update reputation, we'll have another requirement. So 4 requirements are what we get here. So it requires that the has updated reputation of the, so there are 2 parameters. So one of them is, the first one of them is the message sender. So here we have the user and also the message sender. So msg dot sender to the user, and so it's Boolean, so it shouldn't exist. If this kind of vote has existed, this kind of updating the reputation has it does exist, then we should say that you have already updated or given score to this user, right? So don't forget about this semicolon, and let's save this. As you can see, it's successfully compiled, and now we can test our smart contract another time. So let's deploy this right over here, and let's take a look at this smart contract. We'll add the Alice and register the user and add another user, for example, Sarah. Register the user. So imagine that each user can give a score to themselves too, but here with Sarah we want to give score to the Alice. So I guess this is Alice, so let me check. Actually that's not the address, so okay, so this is not the kind of address we're looking for. I guess this is it, and let me check. No, it's not this one too, and let me check this for, oh, actually we hadn't copied this address. Anyway, so as you can see, this is Alice, and this is the address of the Alice user. So this is the user, and this is the score that we want to get. For example, 7. Sarah wants to give Alice the reputation score, and here we can comment, for example, no comment. And now let's click transact. As you can see, it's been done. If I try to do it again, it must not work. So why is it working here? So it's update the reputation, we saved it, and the message the sender shouldn't give the other user the score. So this is the user that we've entered, so this must not happen again. So I guess we need to also update something else instead of the register user, right? So once we register user or do something like that, we need to also create another kind of struct, right? So actually something that we forgot here was that in this function we should write this kind of mapping within a mapping and set it to true. So once we have updated the reputation, this should be equal to true. So once it gets true, then it's alright. So the same thing happened in vote3.sol when we set the has voted of the message sender to true. So anyway, here this one should be added as well. And now let's save the smart contract, deploy it again. So now we can deploy this, open the instance of the contract. So let's choose the first address, add Alice, register the user, also add the second address Sarah, register the user, and now we can test it. So for example, with Sarah, we can vote for Alice. Actually, we can give the score to Alice, and the reputation score here is, for example, 8, and the string related to comments, no comments, for example. And then we can click transact, and let's do it again. As you can see, we will face this error. You have already given the score to this user. So just like that, we can create a mapping and set it to true, and just like that, we can find the problems and solve them through the smart contract and testing them here in the Remix IDE. So Remix IDE will make it easier for you to test the smart contracts, so that then later you can write the smart contract on VS Code and actually copy it there and then interact with it using different frameworks. So here is this is it for the testing. You can also solve the other problems. So for example, if a specific address has a specific user, then this mapping also needs to be done here. So for example, so that you cannot register with one address for different kinds of user with different names. So that here we will not see that, for example, the user count is 3, but we have 2 users, right? So here this mapping from the address to the user should also be applied here. We've added this kind of mapping, but we've only used it. So this should be also a Boolean too, right? So from the address to Boolean, we should consider that the user is also registered, right? So the mapping from the address. So I think in this in this tutorial, you actually comprehended the mapping reason. The reason we use mapping. Mapping is for a kind of a functionality that is one-to-one, so that this thing is for the other. And this kind of example is for the one-to-one, only uses the Boolean, right? Boolean variable. So from one address to Boolean, or for an address to an address to Boolean. So kind of the mapping instead of a mapping. So these practices in the future will help you a lot in order to solve the problems of a smart contract, and you can comprehend your own projects by yourself single-handedly. This is a very good, I think, tutorial for you to comprehend the mapping. So we've got this mapping, and we will get the has registered variable registered. There we go. And then here, once we register a user, it will add the requirement. It requires that the address, or actually the has registered of the address not be true. So actually of the message sender, msg.sender, and otherwise you can say already registered. Here we go. Let's also add, once we pass this test, we need to also set this to true. Otherwise it won't work for us. So once we do it, we can save this, and let's deploy the smart contract another time. So now we can register this user, the first one. So actually here we can put a name instead of that. So here we can add, for example, with the very same address, we can register Sarah, but it won't allow us because of this kind of mapping that we have written already registered, right? So that gives us this capability to have this one-to-one mapping for a specific address to a specific name, and that's just fine. So let's get the user count. As you can see, it's 1, not 2, but at the time when we hadn't this kind of has registered variable, we would have 2 users and there were 2 names for 1 address. The most final name would be the name of the address, but there were 2 users considered in the user count. So with that said, we have solved the problems for this smart contract. We've comprehended it, tested it, and tested all the functionalities in order to make sure that it works fine. One of the good practices for you is to also add the rating to the user so that it counts the number of votes or scores that they given, so number of people who have scored, and also right now it has the sum of all of the scores that have been given. So for example, we saw that 2 8s became 16, and then actually divide this score by the number of people who have given the score, and then add another option, get rating, to this smart contract. So that's it for this tutorial, and until the next one, goodbye.